learn how to solve quadratics by square root. We just got done solving them with the graphs. So again, quadratic, you have to have a squared term. If you don't see the x squared, then you don't have quadratic. So if we see something like this, y equals x squared, that's quadratic. Many times we might have the a, b, c term, that's going to be helpful. But the roots or the zeros, when we graph them before, the roots or the zeros are where across the x-axis. So for instance, maybe this one's at -2 and +2. Those would be the zeros, so that's still true. But we're going to look at those and solving them with algebra now rather than using the calculator or the computer to solve it. So when do we solve by square root? When the b term is 0. So when would the b term be 0? We're going to see that over here. Let's remember when we solve equations, we use the inverse operation. So for instance, over here, 3x equals 12. What do we do to solve that? Divide by 3. That's the inverse. Right now it's 3 times x. We divide by 3, we get x equals 4. Just reminding us of our algebra skills. What do we do to solve the other one? Subtract 2, because that's the inverse of adding 2, and then you get x equals 3. So those rules apply. We're just using algebra. It's something we already know. So in here, real quick calibration. This says n squared equals 81. So if you took your calculator and you looked on your calculator screen, it actually tells you the inverse. If you see this squared button, the x squared button, right above it in yellow on yours and blue on mine is the what sign? What sign is right above that? What do we call that? The square root sign. So that's the inverse of squaring something. So if I were to square root this, I would get n. And the other side, now you can use your calculator. You can take the square root of 81 if you don't know. But what times what is 81? 9. There's one trick to these, though. When you take a square root in an algebraic equation, you have to know there's 2 possible answers. It could be 9, but it could also be -9. You say, how do I know that? You have to memorize that fact that whenever you take a square root of a square, it could be positive or it could be negative. So the answer to this one is positive or -9. Now, if I take 9 and I plug it back into the equation and I square it, I'll get 81. If I take -9 and I plug it back in, now notice I put it in parentheses and I square it, I get 81. Some people might mess up and they do this. And that is a mistake because you didn't substitute -9 in. You substituted 9 in and then made it negative using the order of operations. So that's why you have to, when you put it in as -9 squared. So -9 also will work in this equation to get you a positive 81 because a negative times a negative is a positive. All right, now part B, let's use inverse operations. First, what do we normally do here? It's just algebra. What should we do to solve this? Add 35. We've done stuff like that many times. So then 5x squared equals positive 35. What next? squared equals 7. Okay? Now, I didn't show divide by 5, divide by 5. I think we're at a place, I don't even think you need to show that add 35, add 35. You can, you don't have to. But now, to undo the squared, I take the square root. And you're like, well, what is the square root of 7? I don't know. You can grab your calculator and you can put square root of 7. And it says it's 2.65. We'll round it off to a couple decimals. So x equals 2.65, but I have to remember, anytime I take the square root, it could have been positive or negative 2.65. All right, let's try part C. First, let's add 8. Where x squared equals 8. Now let's divide by 4. Now, as soon as you get x squared, you're going to take the square root. Question. Yep, that's why it turned to 0. And then we added 8 to the other side, and it turned to 0 plus 8, so it turned to positive 8. Make sense? Okay. Now the square root, when you take the square root, you make sure you turn it to a plus or minus, and 1.41, is that what you said? Okay. All right, the next one. We subtract 4, we get negative 4. Now in the calculator, if you do the square root of negative 4, we're going to get to the point where we talk about these things called imaginary numbers. But right now, what does the calculator say when you do square root of negative 4? No real answer. Because, so this one, there's no answer, no real answer. We'll talk in the future in another lesson that there will be an imaginary answer. That sounds kind of crazy. But right now, there is no answer. Why? Negative 2 seems like it should work, but a negative times a negative is a positive 4. You can't take the same number times itself and get a negative. Positive 2 times positive 2 would get us positive 4. I can't take the same number times itself and get a negative 4. Does that make sense? So there's no real answer that will work for this one. As soon as you put a negative under the square root sign, it's not going to work. Now this one, we subtract 16, we get 0, subtracting 16. We divide by 3, we get 0. We take the square root, we get 0. And now you say, what about the plus or minus? Here's the thing, 0 isn't positive and 0 isn't negative. It's the only number that's neither. It's in between all the negatives and in between all the positives. It's this middle value between positives and negatives. It has no value. The definition of 0 is the absence of value. Okay? All right, see if we can do this one. What do we do first? Add 18. Add 18, we'll get 18. Now what? Get rid of a half. To get rid of a fraction, you multiply by its reciprocal, 2 over 1, or multiply by 2. So m squared equals 36. Now you have to take the square root of it. Plus or minus 6. Remember, it's plus or minus anytime you do that. An aquarium is designing a new exhibit to showcase tropical fish. So hopefully you can see the three-dimensional idea there. I don't know how good you are at drawing in 3 dimensions, and I'm not going to be very good on this part of the board because it's got that wrinkly piece. But can you picture putting stuff into the aquarium? That's the idea, yes? So the exhibit will include a tank that is a rectangular prism. Now, a good idea of a rectangular prism is like a cube of butter, and then just make it bigger. Or a shoebox is another one. But if you've seen an aquarium, that's a good example of a rectangular prism as well. It's in a rectangle shape. The volume is 420 feet squared. Now, it gives us a formula. Volume equals H, or length times width times height, LWH. So we're going to fill this in. It tells us the volume is 420 cubic feet. So instead of V, I'm going to put 420 in where I see a V, length, width, height. Now it says the length is twice the width. And let's see, what does it say about the height? Oh, in the picture, it says the height is 3 feet. So we got to get the rest of this information. So it says in the problem the length is twice the width. So instead of putting in length, I'm going to put 2W because the length is 2 times the width. Does that make sense? Then the width is still going to be W. And the height comes from the picture. The height is 3. You might say, how does this work with what we just got done doing? You're going to see, hopefully. Does everybody understand what things I did here? We did some substitution. Substitution, just replacement, according to the reading. And everybody understand where all the numbers are coming from now? Okay? So now we're just going to try to solve this. 420 equals 2 times 3 would be 6, and W times W. How could we rewrite that? W squared. Oh, now it looks like one of the problems we just got done doing. What are we going to do first? Divide by 6. If you divide by 6, 70 equals W squared. Now, we take the square root of 70. What? 8.33? 8.36. Now, you say, wait a minute, when I take a square root, it can be positive or it can be negative. But here's the question. Sometimes it can't be. Can I make the width a negative value? A negative width doesn't make any sense. So the width is 8.36 feet. We know that the height was already 3 feet. What is the length? On your calculator, hit times what to get the length? The length is what times the width? 16.7. What is it? 16.7. 16. What'd you hit to do that? Times 2. Now, let's see if it all comes together. Now, realize when you round things off, it's not always perfect. But what's supposed to happen is if I take the length, which is, I forgot already, 16.72, times the width, 8.36, times the height of 3, it should equal about 420. Does it? And just because we rounded a little bit, but that's the idea. Now we have the length, the width, and the height. The original tank wasn't big enough. The new height is 4 feet, and the volume is 500. What's the approximate width now? Oh. So we're replacing this with 500. We're still having 2W times W, and the new height is now 4. So 500, 8W squared, good. Divide by 8, what's W squared? I think it's 62.5 if you make it a decimal. When you divide 500 by 8, put a dot on it. Is that right? Okay. So we know the length now is 2. The width, take the square root of that, and it's going to be 7 point something this time. Give me 2 decimals again. Square root of 62.5. 0? 90. And oops, that's supposed to be height. Height was 2. So the length is twice that, so 15.80, I think. If that is right, times 2. Yeah. 15.80. So then let's take length times width times height. See if we got it right. 15.80 times 7.9 times 4 is about 500. And you're like, why is it always a little bit too small? We rounded. Yeah, if we kept all the decimals, it would get us more accurate.